I'll write this as an example. So I started with 8, and then what did I do? Remember? Divided by 2. So then I had 8, 4. 4 divided by 2 is 2. 2 divided by 2 is 1. 1/2, 1/4, 1/8, and so on. And we did write an expression for the a sub n term. I think we wrote 2 of them. Okay, so if n, the term number, if the term number is 1, it starts with 1, then we had an expression for the a sub n term. Let me kind of partition that a little bit. And what was it, by the way? Let's see. I looked at this and said, okay, the first term is 8. How do I get the second term from the first term? Multiplied by 1/2. So I'll do times 1/2. To get the next term, I did times 1/2. So the a sub n term was the first term times 1. How many 1/2s do I need for term number n? We need n minus 1. That is if n starts with the number 1. So if n starts with 0, what is it? Is this n? If n starts with 0, then a sub n is 8 times 1/2 to the n. And then n is 0, 1/2 to the n is 1. The first term is 8. So I have that. And the little blurb at the top there, we could think of this as a function whose domain is just the integers. So let's do this. Let's compare this. I'll use the one where n is starting at 0. Compare a sub n is 8 times 1/2 to the n to f of x, which is 8 times 1/2 to the x. So what is the difference there? Sequence, n is an integer. Here, I want to graph this guy right here. Actually, you could do a little chart. I guess we kind of have a little chart already. When x is 0, what is y? What is f of x? 8. So here, I'll put 8 right there. When x is 1, then f of x is 4. When x is 2, it's 2. And this is, now I could put in, what happens if it's negative 1? 16. So I'll put that one in. And so for a continuous exponential function, I'd get something like this. For the sequence, and if I define it n is greater than or equal to 0, for the sequence, I just get the dots. See, when I plug in 3, I get 1, with n starting at 0. If I plug in 4, I get 1/2. So sometimes we might want to think of a sequence as a function where the domain is restricted to the integers. And we would say that a sequence converges if, as n approaches infinity, the terms of the sequence get closer and closer to a certain number. And we've kind of been playing around with that. I don't think I've officially written that out for you. So we say that a sequence converges if, as n approaches infinity, the terms of the sequence get closer and closer to a certain number. So I would write, here I'll write it this way. Let A sub n be a sequence. And in this case, I have n is greater than or equal to 1, but that could vary. That sometimes on WebAssign, they might start it with 3 or 4, or sometimes we'll start it with 0. So I have this sequence though, and I could say this. If the limit as n approaches infinity of A sub n is some number L equals L, then the sequence converges to L. If a sequence does not converge, then it diverges. If a sequence does not converge, then it diverges.